Here is the Wi-Fi antenna I built. It works at a frequency of 2.4 gigahertz, and it's the Yagi style. It includes a lot of 3D printed parts, and it's mostly metal. It has an SMA connector on the end, and I'll show you how I built it. So here's my plan for the antenna. There's really no one way to design any antenna, but this is how I did it. I'll include specific details of my design in the description. Once I had the design figured out, I was ready to put it all together. So to hold all the elements as one piece, I decided to go with this angle aluminum I had, just because it was laying around. And then since aluminum conducts electricity, I wanted to keep all the elements isolated. To do that, I designed some blocks that I could 3D print. So then I was ready to print it out. I started by printing just one, because I wanted to see if it worked. So it took about 10 minutes to finish, and when I tried it out, it took a little bit of filing, but it fit eventually. At that point, I realized I could print more of them, so I printed another 7 of them. Even though this is a 9-element antenna, I only printed a total of 8 of these blocks. That is because I wanted a separate one for the dipole, the driven element, which is what you see here. It's essentially the same as the other blocks, except I cut a notch out of the top of it, and there was a little bump to keep the 2 elements of the dipole isolated. Then it was back to filing all of them, which certainly took a while, but they all fit eventually. The good thing about having them press fit is that there's no extra hardware required, and they won't move if you don't want them to, but you can certainly adjust it if you need to. So I was able to get them all on, and then for the actual elements of the antenna, I used this 2mm diameter garden wire, which I cut with end cutting pliers in a bag. I did this so that nothing would fly into my eye. And then I designed the blocks so the holes in them were pretty much 2mm in diameter, so that meant that everything was a press fit. I usually had to use pliers to help me get them in, but after some time I was able to get all of the directors and the reflector in, which is what you see here. And then I also spaced all of the blocks apart. And then here you can see the 2 elements of the dipole. They're not connected to anything, which is why I'm getting this SMA cable. I cut a reasonable size piece. I didn't want it to be too long, but I didn't want it to be too short either. So I cut that, and then I stripped it so I could take the ground wire and connect it to one side of the dipole, and then connect the signal wire and connect it to the other side. And then for a better connection, I stripped a little bit more of the wire so I could loop it around the dipole. And I also shaved off a bit from the element so I could loop the wire around it. So then it was time to solder. So here it is before, I had it all taped up so it was more easy to solder. And then here it is after. I'm just checking all the connections to make sure everything's connected to where I want it to be, and then also that nothing's connected where I don't want it to be. I was pretty thorough with this, but in the end everything seemed to work out. And then once I knew that everything was connected correctly, I covered everything with hot glue to make sure it wouldn't come apart. And then I also colored over the top of the hot glue with Sharpie just because I thought it would look better and would blend in with the rest of the blocks. And then once I removed the tape, I realized that there was some exposed wire, so I covered that with electrical tape. And then I also put some more hot glue to reinforce it so that the wires wouldn't get ripped out. And that was it. This is the final antenna here. I do think there was also some things I could have improved upon. The biggest thing probably being my soldering, since I don't feel like the garden wire is the best material to solder. I don't think it was designed for that. And then you may be wondering how I'm going to hold it up. I'm just going to use my third hand. I'm not going to drill a hole through it. So then I was ready to test it out. To do that, I bought this USB Wi-Fi adapter so I could connect the antenna to my computer. It has an SMA connector on the end, so I could just connect it right to it. It looks a lot like a software-defined radio, but the thing with most SDRs is they don't work at a frequency as high as 2.4 gigahertz. So my plan was to take the antenna and this adapter out as far away from the router as possible, which in my case was my deck. So that meant that I could test my antenna pretty much through my entire house. Then to measure actually how well the antenna is performed, I used latency, which is essentially how quickly the antenna can communicate with my router. So when I tried the standard antenna that came with the adapter, I got a little over 150 milliseconds, which isn't very good, but then again, it's going through my entire house and my foundation. And then I tested out the Yagi antenna I built, which is very directional, so I don't think I got it entirely lined up, but I did do some measurements to see how far away it was, and I used some basic trigonometry to figure out what angle to point it at. And then when I tested that out, it was about 107 milliseconds, which was definitely better than the omnidirectional antenna that came with the adapter. And it was certainly better than the internal antenna on my laptop, which had a latency of well over 300 milliseconds. And that was it. I hope you enjoyed watching me put this antenna together. I certainly enjoyed making it. And I'm also going to compare it to another antenna that I made. I used an algorithm that I wrote to design an antenna. I used Python to do that, so keep an eye out for that. And thanks for watching.